This is a great example of a question that most people are going to skip, and that is totally fine. You got to be able to read and understand what they're saying, and that's very, very hard. There are definitely better places to spend your time. So pick a random number if you want and move on with your life. It's not the end of the world. But this is definitely a kind of question we need if we want to get a 750 plus on the actual SAT. They will give us things like this that we've never seen before, and some of you are going to panic. But if we just follow the instructions, it's not so bad. The hardest word here, especially if English is not your first language, is convex. So in a way, it kind of just means it's a pentagon, like a normal pentagon that you would think of, right? A five-sided figure. But it's a little annoying because it's not the normal, like everything is the same pentagon. It's not a regular pentagon. So let's kind of try to follow what they're saying. So AB is parallel to DE. So I'm going to do AB and DE. I think I can just do something like this. A, B, yeah, I think this is good. DE. Now, D goes on that side because I got to put C somewhere, right? So I'm going to put C right here. And I think this will do it. It's not, it's a little less noticeable as oh, actually, let's do this. Let's make it not in the middle. Oop. Let's do it like somewhere here feels right. Okay, so that's C. So you can kind of see it's bending there, it's bending here, and then we're going to have one more side. So how many sides do we have? 1, 2, 3, 4, 5. Okay, and these two sides are parallel. Now a concave pentagon, just to kind of give you an example, would be like something like this, where it kind of opens normal and then boom, it kind of opens in. So it's going to have an angle that's more than 180, a reflex angle. So that's a concave pentagon. So that all of these angles kind of still bulge out is kind of the way I think of it. So we can start putting some stuff on the picture then. We know the measure of angle B is 139. Measure of angle D is 174. So you can see I haven't really drawn this thing to scale, but it's going to be okay. And what is the measure of angle C? So that's what we're looking for. So they were like, oh, well, that's not great. They didn't give us A and E. So that's a problem, right? So what the heck is going on here? Plus pentagon, right? How many angles do we even have in a pentagon? What's the total number? This is one of the first times I've ever seen on the new digital SAT that we need to use this formula, 180 times n minus 2. What does that give us? That gives us the sum of the interior angles of any shape. So of technically an n-sided shape. So in this case, this is a 5-sided shape. So in order to use it, we're going to plug in 5 and solve it. So that's 3 times 180, which I believe is 540, but we're going to do it because I don't want to mess it up. 180 times 3, 180 times 3, 540. So that is the total for this pentagon. And again, the pentagon shape that we're mostly familiar with looks like this, where everything is kind of the same. I'm going to try my best to draw it. And so we normally have just like, oh, divide by 5, and each of those angles is like 72 or something. So that's great. That works. Actually, it's not 72. It's 108. So that would be like here. But this is a weird one. This is an irregular pentagon. So it doesn't work out. But we still know that there's a total of 540 degrees in here. So we already have 139 accounted for and 174, so we can get rid of those. But we need to use the parallel lines to help us with A and E. So the way to do it is to recognize that if I kind of just focused, this is going to be so hard to draw. If I just focused on this little part of my picture, we have that familiar Z shape, but we have two parallel lines cut by a transversal. So I don't know what this is right here. But I do know that because these lines are parallel, that angle outside of A is going to also be the same thing. They are alternate interior angles, and they're congruent. But I don't care about that because that's outside the pentagon. What I do care about is that the thing that's back inside the pentagon at A is going to be 180 minus X, because the two of them have to add up. It's a straight line. So another way to think of it is, yes, we don't know the values of A and E, those two angles, but we do know that together the A and the E have to be 180. You can kind of see it, right? Like take angle E and kind of put it on top of angle A, and you can see that they would form a straight line, right? So another way to look at it is this is also angle E right here. So that's 180 degrees. So I don't care what they are individually, but I know together they're 180. So what this means is now we have our 540 total degrees. We have 180 degrees taken care of from angles A and E. We have 139 from B, and we have 174 from D, meaning that whatever's left over is the thing we want. So I'm just going to go to my regular calculator here, not going to bother with this in Desmos. So 540 minus 180 minus 139 minus 174 is 47, and that is the answer. Yeah. If you're confused, this is, I get it. This is crazy. Once we get the picture, it's not so bad, but it's a lot of geometry for one question. And it's a lot of geometry rules that individually are very easy, but then this question is making us kind of put them together. And it's geometry rules that don't really go together in my mind, right? I don't think I've ever seen an SAT question where we're taking the parallel lines transversal thing and combining it with the total interior angles in a pentagon. Like, what is happening? But just as a bigger lesson about the SAT and PSAT, this is how they make hard questions, guys. There are certain little building blocks, formulas, rules, definitions, whatever, that you're supposed to remember. And individually, those things, there's really no excuse. You've got to memorize them, no doubt, right? So the thing that's, I think, hard to memorize here is that 180 n minus 2. That is not something that's easily accessible to most people. It's just not used very often. But hopefully now you've got it locked into your brain for next time. Odds are you're never going to see it again on the SAT, but still. So those little building blocks, though, yes, you can memorize them individually, but then we get a question like this where we have to put them all together in weird ways. And the SAT, every time they have hard questions, it's that. They're taking different building blocks, they're putting them together, and they're expecting you to recognize which blocks they used and to take it back apart. That is a difficult skill. It comes with practice, but that is how you need to approach the hardest questions on the SAT. If your approach is just, oh, I'm going to learn this, but the convex pentagon question, memorize the steps, and then when I see the convex pentagon question, I'll know exactly what to do. No, you will never see the convex pentagon question again. The point is you need the flexibility, because no matter what, on every SAT and PSAT, you're going to get stuff you've never seen before, no matter how much you've studied. I've been teaching this thing since 2006, guys. I've never seen a question like this. So there you go. It's many, many years of this, and this is the first time I've ever seen a question like this. You will always get infinite variety. Your job is to have enough memorization and enough strategies to be prepared for whatever varieties of things they shove at you, but it's with some dedication, it can be done, but it's also fine to skip this, like I said at the beginning.